Hi lads, this is a continuation of the video on predicting chemical formula. Okay, what we looked at in the previous lesson was the fact that there's different groups. So we have groups 1, 2, 3, 4, 5, 6, 7, 8. On the junior search, you need to know group 1, 2, 7, and 8. So 8 is the noble gases, group 7 is the halogens, group 2 is the alkaline earth metals, and group 1 is the alkali metals. You need to know that the elements in the middle here are called the transition metals. Okay, and you need to know as well that there is a valency here of 1 for group 1. That means that they have a tendency to lose 1 electron to get back to 0. Our valency of 8 on the outside, so it's either 0 or 8 on the outside of these atoms. You have a valency of 2 on these atoms, which means again they have a tendency to lose 2 electrons to get back to a valency of 8. In other words, a full outer shell. Over here, if we talk about group 3, have a tendency to lose 3 electrons, as we said, to get back to a full outer shell. Whereas group 4 has a tendency to either gain or lose electrons. So 4 electrons to get up to 8. And then continuing on here, this is a valency of 3. In other words, it's going to gain 3 onto its 5 electrons to get to 8. This is a valency of 2 to get up to 8. This has a valency of 1, again, because again halogens have 7 electrons and 1 more electron will get it to 8. Okay, noble gases have a valency of 0 because they have, or you could say 8, valency of 0 or 8, because they have a full outer shell. Okay, so valency is important because it tells us something. It relates into this thing we call the octet rule. And the octet rule states that an atom, any atom on the periodic table, has a tendency to try to fill its outer orbit with 8 electrons. Okay, so what we're looking at today really is a few examples. So I'm going to swap over here to this book, and we're going to have a look at how we'd answer these questions if they came up on our exam. So just a little bit of a recap first of all anyway. The first thing anyway is, if we look here at this question here, which element is the most predominant in the compound of CH4? Okay, so predominant means that it is the most widely found atom in this compound. So the other day we looked at chemical formula. Okay, I think this is a little bit small, chemical formula. And we said that there's a certain conventions that we use for chemical formula. And what we can learn from that is that here, after the carbon, this is a carbon atom. We can assume here that this is one carbon atom. Now, it's not written in, and you'd never see 1 written after an atom, because we normally just leave it alone. Okay, but we can assume this is 1 carbon atom. We can see here that we have hydrogen, and what this means here, when I have a small 4 after it, means I have 4 hydrogen atoms. So that means to make a compound of methane, I need to have 4 atoms of hydrogen and 1 atom of carbon. Now, if we look at our periodic table, let's see if their valencies match. Okay, so what we're going to do here is we're going to practice looking at valencies. Okay, so I can see here I have carbon, and carbon is in group 4. Hydrogen, remember, is in group 1. So therefore, the valency here of carbon is it's 4. It requires to lose or gain 4 electrons, whereas the valency here of hydrogen is 1. So if I went back here a second, I could say here the valency here of carbon is 4. Now remember, if I want to have a balanced chemical formula, what I would do here is I'd make sure that that I would have the same number on this side of the ratio. Okay, so we can see here in this they chose 4 hydrogens to match with this, because 4 electrons will bring these 4 electrons up to 8. Okay, so in other words, it'll meet the octet rule and it'll create a stable compound. So a stable compound will have, for the most part, will have 8 electrons on its outer orbit. Okay, so that's how you do that question there. This question was simply asking which is most predominant, and clearly the answer is hydrogen. But if I wanted to have a look here, a closer look at its ratio, this is what it looks like. So let's have a look here at a few of these questions here and do them together, and I'll get you to do the rest for me. So let's say we pick out magnesium oxide, okay, which is part D. Okay, so I'm going to do part D here. So magnesium oxide, Mg. Okay, so the first thing what we'll do is we'll find out what are the valencies of these compounds. Okay, so we have Mg plus, and we have O. Okay, so on the periodic table, we can see here magnesium is in group 2, so it has a valency of 2. It'll tend to lose 2 electrons, whereas oxygen here is in group 6, so therefore it needs to gain 2 electrons. So it appears that these are a perfect match for each other because the valencies are already 2, and if we look at it, 2. So therefore, if we're going to create a stable compound here, then if we look at it, actually magnesium can bond directly with oxygen and it'll create magnesium oxide. Okay, so therefore we've got a stable compound there. So that is that's the first thing anyway. That is creating a stable compound here, where it's pretty straightforward. We actually have the same number of atoms on either side. We have 1 atom of magnesium and 1 atom of oxygen. Okay, and we know that because our valencies are the same. Let's rub this out. Give myself a bit of space. Now, let's pick another compound and let's see, hopefully it won't be an exact match. So let's say we pick out ammonia. Okay, ammonia here, it says nitrogen plus hydrogen. So what we'll do here is we'll write in nitrogen and we'll say plus hydrogen. And what we'll do is we'll create an arrow. So this is going to create a bond and create a compound. So again, what we need to do is we need to look at our periodic table and find what is the valency of nitrogen and what is the valency of hydrogen. So you probably know at this stage that the valency of hydrogen is 1 because it has 1 electron on its outer orbit. And the valency of nitrogen here, we can see it's in group 1, 2, 3, 4, 5. It's in group 5. So therefore it means, now the tendency would be to say that this is a valency of 5, but actually its valency, remember, is 3. Because it needs to gain 3 electrons on its outer orbit. So when I do this ratio, the ratio really is in relation to the valency of the atom. So therefore, it's 3, and we have to make a mistake there, 3. So we have, in other words, 3, and we have a ratio of 3:1. Now, that's not going to work. We can't have a ratio of 3:1 to create a stable compound. It has to be 3:3. So to work this out anyway, we definitely have to have 1 nitrogen at the moment, okay? And we definitely have to have a bond here of hydrogen with it. But it depends now on how many hydrogen we need. So if you count it out, if 1 hydrogen has a valency of 1, how many, if I had 3 hydrogen, how many, what would their valency be? It would be 3. So therefore, if I pick 3 there, therefore the ratio now would be 3:3. So therefore, a stable compound of ammonia, its formula is NH3. Okay, so that is this question here, ammonia now complete. And I can be very confident in that because the ratio is the same, 3:3. Okay, so let's do one other example just so this is really sticking. Okay, so if I look here at the last one here, we'll say potassium bromide. Okay, potassium, remember, has the symbol K. Okay, so I have K, and I have bromide. Bromide has the chemical symbol, which is big B and small r. Okay, so what we would do then is we'd look here at the periodic table and figure out what are their valencies. So potassium, where is potassium on this periodic table? We can see potassium is here. It is in group 1, so therefore it has a valency of 1. okay, and bromide, or bromine rather, is in group 7. So actually this is a really straightforward chemical formula, because if bromine is in group 7, that means it has a valency of 1, and potassium has a valency of 1. So therefore we can see our ratio is 1 is to 1. So therefore you're going to create a stable compound by simply chemically bonding these together. These are going to be highly attracted to each other, and they're going to create a chemical bond, which is Kb and R. Okay, so actually we just need both of them to join together, and we have potassium bromide then. Okay, so that is this section here on chemical formula. Okay, I just want to look at last year's questions. Okay, ammonia we just did, so we worked that out as a ratio here. We said the ratio of ammonia was, we worked out that it was N plus H. Okay, and we worked out that hydrogen was in group 1, and we worked out that nitrogen was in group 5. So therefore nitrogen had a valency of 3, and that had a valency, hydrogen had a valency of 1. So we worked it out there that the ratio is 3 is to 1. Okay, and therefore the formula was NH3. Okay, so actually they're quite simple actually, really. You just need to understand the process here. Okay, so if I was to look at magnesium chloride, just to start you off on that one as well, just so you have an idea, we have magnesium, okay, and we have chloride or chlorine. So again, I look at my periodic table, okay, and I can see here on my periodic table here that magnesium is in group 2, so therefore it must have a valency of 2, and chlorine is in group 7, so therefore has a valency of 1. Now this is a little bit different, okay? We can see here that magnesium has a valency of 2, okay, and chlorine has a valency of 1, because chlorine, yes, it's in group 7, but that it only needs 1 electron to get to 8, so therefore its valency there would be 1. So clearly this is not a balanced ratio. And I suppose what makes this different is that normally we would look at changing the first. Well, actually, no, that's not the case. This is exactly the same. What we need to do here is we need to choose the correct number of chlorine atoms to bond with magnesium. So therefore, we can see here that magnesium anyway it stays the same because it has a valency of 2. But if I change this to 2, then I would have a stable compound. So therefore, I'll have Cl2. Okay, so magnesium chloride. So therefore, each of these atoms will have a valency of 1. So 1 plus 1 gives us an overall valency of 2. So therefore, we have 2 is to 2, if I write it underneath it, and you can see there that that is going to be a stable compound. So actually, the answer for this one here was, first of all, the ratio was 2 is to 1. Okay, so 2 is to 1. And we can see here that this was MgCl2. And I can't write that in there, but you get the idea. Okay, so that is the chemical formula. That's as much as I'm going to do in chemical formula. You can practice these questions. So what I'll do is I'll assign a few of these questions to you, and you can have a go with them. Okay, so look, we'll talk to you later.